Good evening. Today we will discuss about the past paper questions from the chapter Aldehydes, Ketones and Carboxylic Acids. Before moving to the past paper questions, let us discuss some of the important topics from the same chapter. So let us go through the topics first. I hope everything is audible. So let us start now with the topics from the chapter. Aldehydes, ketones, and carboxylic acids. First of all, we have to know what are these three type of compounds. All these three compounds are containing carbonyl group. Carbonyl group is the CO group which is present in aldehydes, ketones and carboxylic acids. Here we can see how we are representing the carbonyl group, that is carbon is doubly bonded to the oxygen and the remaining two valencies of carbon will be satisfied by some other groups like R, hydrogen or something else. R means aryl group or like that. So this carbonyl group is common in aldehydes, ketones, and carboxylic acids. So based on the substituents coming here at the position of A and B, we will get different kind of compounds. They are aldehydes, ketones, carboxylic acids. So let us consider the reactions. So let us consider them. Here the geometry, first of all, we can see the geometry of the carbonyl group. It is trigonal planar because this carbon is containing three bond pairs. So these three bond pairs will arrange in trigonal planar geometry. So the geometry of the molecule will be trigonal planar, but the rest of the molecule doesn't have to be planar, means only this part will be trigonal planar. The remaining R group may be whatever it is, it may be different. The remaining, so the geometry around this carbonyl group is actually trigonal planar. Whatever the group is remaining is not planar actually. So this is the structure of the carbonyl group that we can see. Now coming to the, so this is the carbonyl group, trigonal planar geometry. Okay. Now coming to the compounds containing carbonyl group. So for an aldehyde, this is the carbonyl group, right? So in case of aldehyde, one side will be the alkyl group. Alkyl group means it may be whatever like methyl group, ethyl group. Okay. Then the other side will be the hydrogen. So this is simply the aldehyde. Okay. Now coming to the ketone, it will be like both the sides will be having R group like this. So in ketone, the hydrogen from the aldehyde is replaced by the alkyl group. So this is the difference between aldehyde and ketone. Now, if you're coming to the carboxylic acids, it is again similar. That is, the CO group is there. One side is the R group and other side is the hydroxyl group. This is called carboxylic acids. So this is the difference between all these three kind of compounds: aldehydes, ketones, and carboxylic acids. If you consider these three here, we can see this represents the aldehyde. This is also aldehyde. This is methanaldehyde or formaldehyde, right? Because this is containing only one carbon. This is ethanaldehyde because it is containing two carbons, and this is actually it is a cyclic aldehyde. Okay. Now, ketones, as we discussed before, the carbonyl group is connected to two alkyl groups, that is R and R dash. So here we have examples. Sometimes the R and R dash may be similar. For example, in CH3, COCH3. Here both the R and R dash are similar, right? But in some cases they are not similar. Depends. Okay, that is the thing. Now, in these three compounds, we can see the carbonyl groups are there. So they all are ketones having different alkyl groups. Now, carboxylic acids, as I discussed, now carboxylic acids are also containing carbonyl group. One side will be the alkyl group and other side will be the hydroxyl group. So this is what is happening in case of carboxylic acids. Okay. Yes. Now let us see esters. Esters are another kind of compounds and they are produced from alcohols and acids, right? So coming to the esters, actually they are having the ester linkage, that is COO linkage. That is important. Here we can see in all these three compounds there are COO group. So actually we can say that this is the carbonyl group. One side is R, other side is OR dash. This is called ester. Okay. Now the compounds containing carbonyl group. So what are the another compounds containing carbonyl group? One is amide. Amides means the compounds will contain CONH linkage. That is COR will be there. This side will be some NH group or something. These are called amides. So these compounds can be also classified into the compounds containing carbonyl group. Now let us see the compounds containing other compounds containing carbonyl group. Here we have amide. Now let us see the compounds containing the amide group. So these are the examples. Here we can see different amides where they are having CONH linkage. Okay, that's it. Now coming to the oxidation reactions of these compounds. Okay, if you take the uh, alcohols, alcohols means they should be primary alcohol, right? So primary alcohols, when they are undergoing oxidation, they will convert into the aldehyde, while when you are taking a secondary alcohol, they will convert into ketone by oxidation reaction. So commonly we can say primary alcohols will convert into aldehyde, and these aldehydes can be further converted into carboxylic acids as well. Okay, now if you come into the secondary alcohol, they will be converting into ketones by oxidation reaction. This is the thing happening in case of oxidations of aldehydes and primary and secondary alcohol. This can be used for the preparation. This can be used as a preparation method for aldehydes and ketones as well. Okay. Now here we have some other examples for cyclic ketones. Cyclic ketones means the keto CO group will be a part of cyclic group, cyclic ring. Okay, so this is not attacking to the ring. This CO group will itself it will be a part of the cyclic ring. That is called cyclic aldehydes or sorry cyclic ketones. Okay. Now let us see the nomenclature for aldehyde. Here, in order to name the aldehydes, we have to use a suffix al by removing the e. From alkanes, we are removing e and adding al. So this is how we are naming the aldehydes. And if there is any branches or something, we have to add that as well. Okay. So here we can see some examples, that is one carbon containing compound. So the stem word will be meth and the name is methanol. Okay. And the formaldehyde. So formaldehyde is the common name. Similarly, two carbon containing compound is ethanaldehyde, and ethanol is it is ethanol. Acetaldehyde is the common name. We can call it as ethanaldehyde as well. Then we have propanol or propanaldehyde, butanol or butanaldehyde. Okay, these are the compounds. Now coming to the nomenclature of ketones, we are removing E and adding the suffix ONE. Okay, this is how we are naming the ketones. Now coming to the this is how we are naming some important common ketones. And see, this is the difference. Ketones will be propanol, three carbon containing aldehyde will be propanol. That is it. Okay. And now we can see the positional isomers of ketones. Usually, in ketones, we can draw the position isomers. First of all, we have to know what are position isomers. Position isomers means there will be a difference in the position of the carbonyl group, right? But in case of aldehyde, we can't draw the position isomers. What is the reason? Because in aldehyde, we know that the carbonyl group is connected to one hydrogen, and remaining will be the alkyl group, right? So it is possible if the see, this aldehyde group cannot come in between, because at that time we have to replace the hydrogen. When you replace the hydrogen with some alkyl group, it becomes ketone. So aldehyde group or CHO group, it will come always at the end of the chain. That is, it will be like this only at all time. So we cannot change the position of the aldehyde group, right? So they cannot produce the position isomers. Okay, while in case of ketones we can change, because this carbonyl group, see, in 3 pentanone 1 2 3, this is the third position, and 2 pentanone it is 1 2, that is in the second position. So this is how we are changing the position of the carbonyl group, right? Okay, now there are some common aldehydes and ketones that we are using in industrial field and everything. Okay, see, 2-heptanone, butanedione, carbon, these are the aldehydes. Okay, now we are moving to the physical properties of aldehydes and ketones. Usually, in whether it is aldehyde or ketone, the carbonyl bond, that is CO bond, will be usually polar in nature, because the carbon atom has a partial positive charge, oxygen atom has a partial negative charge, so they are polar. That is the first thing. So, due to this polarity, they are having different chemical reactions and the physical properties are also different. Okay, this is the thing. Now, see, due to this polarity, they can produce the hydrogen bonding, means they will be soluble in water. Okay, so due to this solubility, due to the process of hydrogen bonding, they can produce hydrogen bond with water, and they will produce the corresponding soluble product. Means they are soluble in water. That's it. Okay, now physical properties, see how the aldehydes or ketones are soluble in water because they are producing hydrogen bonding. Now we have to know the preparation methods as well. As we discussed before, the primary alcohols can be oxidized and they will produce the aldehydes. Similarly, secondary alcohol will produce the ketones. These are the preparation methods, and the reactions also. The aldehydes and ketones can be differentiated by tolerance test. Okay, and these are the reactions of aldehydes and ketones: acetal formation, hemiacetal formation. These all are important. Now let us see some questions from these topics. Okay, the first question: which among the following is filling solution A? Actually, as we discussed before, filling solutions are usually used to uh, differentiate between aldehydes and ketones. So, this filling solution is a mixture of two filling solutions, that is, filling solution A and filling solution B. So, we have to find out which is the filling solution A. So, first, I will write what are filling A and B. Hmm? Filling solution is aqueous copper sulfate, and filling solution B is alkaline solution of sodium potassium tartrate. So these are filling A and B, and mixture of these A and B is called filling solution. Okay, so now let us see the options. The first option is filling solution A is an alkaline solution of sodium potassium tartrate. This is not the correct answer, right? Now coming to the second one, aqueous sodium citrate. This is again incorrect. Aqueous copper sulfate is the correct answer, which is the filling solution A. So aqueous copper sulfate is correct. Alkaline copper sulfate is also wrong. Okay, so filling A is aqueous copper sulfate. Filling B is alkaline solution of sodium potassium tartrate. So this is the answer for this first question. In this question, we have some reagents. You have to choose the reagents in which the glucose does not react to give the corresponding test or products. Let us see the first one, tolerance reagent. The glucose can react with tolerance reagent. So this is not the correct answer. Coming to option B, Schiff's reagent. Glucose cannot react with Schiff's reagent. Okay, so this will be one answer. And coming to HCN, they can react. So this is not the correct answer. Then option D is NH2OH. This is also reacting. And NaHSO3 sodium bicarbonate, this will not react. So the compounds in which the glucose do not react are E and B. So the correct answer is option A. In this question, we have to select the incorrect reaction from the options. So let us see the options. In the first option, acyl chloride is converting into carboxylic acid by heating with water. This is a correct reaction because this reaction is possible. That is, acyl chlorides on heating with water can be converted into acid. Okay, now coming to the option B, here an amide is converting into an acid by reduction because lithium aluminum hydride is a reducing agent, right? So let us consider the reaction. Actually, in presence of lithium aluminum hydride reducing agent, the amides are not converting into acid, but they can convert into amine, means the CONH2 group will be converting into amino group. So this is the reaction because here what is happening, the reactant that is containing this amide group CONH2, this CO group will be converting into CH2 group. Okay, so this carbonyl group is converting into a hydrocarbon by the reduction with lithium aluminum hydride, and they cannot be converted into an acid. So option B is not the correct reaction. So they are asking for the incorrect reaction. So option B is the correct answer for this question. In this question, we have to find out or identify the product A of the given reaction. And in this reaction, we can see a ketone containing two carbonyl groups reacting with zinc amalgam and concentrated hydrochloric acid. So zinc amalgam and concentrated HCl. This is a reducing agent, right? Means they can do the reduction, they can remove oxygen, and they can add hydrogen. So here, when this compound become reacting with zinc amalgam and HCl, these two carbonyl groups will undergo reduction and they will convert into CH2. That is, CO group will convert to CH2 group. This is happening actually. So here we can see in the first option, this is the whole thing is converting into CH3. This is not possible. Here also, right? So this is not the product. Now coming to option B, here also we can see the CO group. This part only got converted to CH2 group and this part only converted to CH2 group. So this is the correct answer. Means CO group only will be converting into CH2 group. Okay. Now coming to option C, if you so B is the correct answer. If you check option C here, they are converting into C. O group is converting into COH. This is also not possible here. So option C is wrong. Okay. Now coming to the option D, here as we know this is converting into CH2OH, CH2OH. This is also not the correct answer. So correct answer is always B. In this question, we have to complete the given reaction. That is, in the first reaction, the given cyclic ketone is converting into a product B, and we have to find out what is C in this reaction. So here, the product B is reacting with concentrated sulfuric acid, right? So first of all, let us write the overall equation. That is reacting with HCN, and they are producing OHCN. And this thing again reacting with concentrated sulfuric acid. Here, the product C will be an acid, that is COOH, and there will be a double bond as well. So correct answer is option A. In this question, we have to find out the major product of the reaction. This is a ketone, and they are reacting with ammoniacal silver nitrate solution, right? So when a ketone react with ammoniacal silver nitrate solution, that reaction is called tolerance test. And this ammoniacal silver nitrate is the tolerance reagent. So here the product is usually they are COCH3. This is the reactant. So the product is this is the product obtaining here. So the correct answer is this question. We have to find out the product Y in the given reaction. So here we can see Grignard reagent RMGX reacting with CO2, right? So first of all, let us write the reaction. CO2 react with RMGX. Then here first thing is this RMGX is having minus part R plus part containing the magnesium. So the first step is this negative charge will attack this carbon. Okay, now they will, because this is positive, this is partially negative. So the negative R group can attack the positively charged carbon. Okay, now you are getting R COO MgX plus plus. Okay, now this will undergo hydrolysis in presence of S3O plus, and they will produce R COOH because hydrolysis will take place here. So you can write the hydrolysis like this. Plus the other product is X. Okay, so these are the product you are getting here. So this is the intermediate actually. The final products are not given in the options. So you can see this intermediate in this option, that is option D, which is the correct answer. So these are the questions from aldehydes and ketones. Hope these questions are clear. So in the next class, we will discuss some other chapter. Okay. So winding up. Bye. Good night.